Hi, I'm Gavin, technical founder of Accessor Labs, and today I'm going to walk you through a new type of exchange we call Liquidium. Liquidium restores trust in crypto exchanges through a fund assurance mechanism based on what's called a validium. Before I tell you exactly how that works, we'll need to explore the architecture of present solutions. In centralized exchanges, user transactions are not actually recorded on the blockchain. Instead, they're recorded in a traditional database off-chain. In this model, you don't really own your cryptocurrency. The exchange controls all your crypto funds, which are held in aggregated wallets or omnibus accounts. This approach is highly performant and usually comes with higher liquidity and trade volume. The model also provides insurance and regulatory clarity as the exchange may be operated by a known legal entity. As the transactions also happen in private servers, the transaction data may be hidden from public view. In contrast, a decentralized exchange allows users to perform transactions directly through smart contracts secured by a public blockchain. In this model, each user holds their own wallet and has full control over their own funds. This type of exchange is theoretically more secure, as it's not subject to the trust assumptions associated with a centralized model. Our hybrid exchange model strikes a power balance between the exchange and its users. Liquidium protects users by preventing the exchange from moving funds without valid signatures, but it still provides the ability to take action against bad actors by allowing an exchange to cut off access to those funds whenever necessary. This is possible because the computation and state are in full control of the exchange, but the use of funds themselves are secured through zero-knowledge proofs validated periodically on the blockchain. It sounds a little magical, so let's unpack the core mechanisms that make this possible. At the center of this approach is a Merkle tree. In the Merkle tree, all the nodes at the bottom are discrete pieces of data. Each layer up is then a hash of its children. This means the top hash is a unique representation of the entire tree. Whenever we change some piece of data at the bottom, like the amount of money in the account, this creates a path of new and unique hashes all the way up to the top. It's important to note these hashes are practically impossible to fake without knowing the data used to create them. This allows us to use zero-knowledge cryptography to prove the account exists, that it holds the correct funds and matching public key used in the signed transaction, which updated the tree to a new and proper state, all without revealing any information about the tree itself other than the top hash. We can bundle many of these transactions and validate them on top of a layer 2 scaling solution. This multiplicity of scaling brings us within the range of throughputs seen on centralized exchanges. Also, using a modular approach, we may selectively include extra pieces of data down into the decentralized public layers below. This could be useful, for example, if we wanted to provide extra auditing functionality. This has been a brief walkthrough of our hybrid exchange, a layer 3 application-specific validium we call Liquidium. Thank you.